High in the Andes Mountains, ancient stone cities stand as silent witnesses to a lost engineering genius. No wheels, no iron tools, no mortar. Yet the Inca built some of the most earthquake-proof enduring structures on Earth. To have your curiosity ignited. Welcome to Inca engineering marvels that still can't be explained. And as we explore, think about it. Which of these incredible achievements resonates most with you? Let us know. Goes, lacked iron tools. They didn't have the wheel for transport of heavy goods, nor did they possess a system of writing to pass down complex engineering blueprints. So, how did they achieve this laser-like precision on stones that would dwarf a modern truck? Were they pounding them into shape with smaller, harder river cobbles? The energy and patience required would be monumental. One popular theory involves a meticulous process of scribing and coping. This suggests that a stone was roughly shaped, then lowered onto the stone beneath it. The points where the upper stone touched the lower one would be marked, perhaps with pigment. The upper stone would then be lifted, and the marked areas painstakingly ground down. crumbling when subjected to lateral forces from an earthquake. Spanning over 25,000 miles, the Inca road system connected the empire, from the Amazon jungle to the Pacific coast. Built without wheels or horses, it featured rope bridges, stone causeways, and cliffside staircases. Imagine an empire stretching for thousands of miles, encompassing some of the most diverse and challenging terrains on Earth, from scorching coastal deserts to humid Amazonian rainforests, and soaring Andean peaks reaching altitudes where the air is thin and the weather unforgiving. Now imagine administering and connecting this vast realm without the benefit of wheeled vehicles, or even draft animals like horses or oxen, which were unknown in the Americas before Columbus. This was the challenge faced by the Inca, and their solution was the Capac Nan, the Great Inca Road. This was not just a road, it was an arterial system, a network of over 25,000 miles, that's roughly 40,000 kilometers, of meticulously planned and constructed pathways. To put that in perspective, the circumference of the Earth is about 24,901 miles. The Capac Nan was an engineering marvel that rivaled and in some aspects surpassed the famed Roman road system. It was the backbone of the Inca Empire, facilitating communication, transport of goods, and the movement of armies with astonishing efficiency. Messengers, known as, could relay information across the empire at incredible speeds, covering up to 150 miles a day in a relay system. The construction of these roads varied dramatically depending on the terrain. In the highlands, they were often paved with stone, carefully graded to manage steep slopes, and wide enough for several people or a train of llamas to pass. They featured retaining walls to prevent erosion and drainage channels to manage rainfall, a critical consideration in the Andes. Where the road traversed marshy ground, stone causeways were built, elevating the path above the waterlogged terrain. These weren't just simple dirt tracks, they were engineered thoroughfares designed for durability and all-weather use. Perhaps the most iconic and daring features of the Capac Nan were the suspension bridges, woven from ichu grass or other plant fibers. These bridges spanned deep gorges and raging rivers, some stretching for hundreds of feet. Imagine crossing a chasm hundreds of feet deep on a bridge made of twisted grass, swaying in the wind. It required immense skill to construct these bridges and constant maintenance to ensure their safety, as the organic materials would naturally decay. Communities were tasked with rebuilding them every year or two, a tradition that continued in some remote areas for centuries. Chapter 4, Ollantaytambo's Granite Giants, a Quarry Conundrum. Ollantaytambo features granite blocks moved from a quarry 6 kilometers away, across a river, up a mountainside. How? No records, no pulleys, just theories involving ropes, sledges, and lots of human power, or perhaps something we haven't discovered yet. Ollantaytambo. The name itself evokes a sense of ancient power and mystery. This formidable fortress temple complex, strategically located in the sacred valley of the Incas, presents us with yet another profound engineering puzzle, particularly when we examine its magnificent Temple of the Sun. This unfinished marvel is constructed from 6 colossal monoliths of pink granite, each weighing upwards of 50 tons, standing upright and fitted together with that hallmark Inca precision. But it's not just their size and fit that astounds, it's their origin. These massive granite blocks were not quarried locally. The source of this specific type of granite is a quarry called Cachicata, located about 6 kilometers or nearly 4 miles away. That distance alone is significant, but the journey these stones undertook is what truly boggles the mind. They had to be transported down a steep mountainside from the quarry, across the turbulent Urubamba River, and then hauled up another steep incline to the construction site of Ollantaytambo itself. Chapter 5, Tipon's Whispering Waters, Hydraulic Mastery of the Ancients. Built centuries before modern plumbing, Tipón showcases advanced hydraulics, pressure control, and agricultural terracing. The water channels are still functional today. In the realm of Inca engineering, it wasn't just about moving and shaping stone, it was also about mastering the lifeblood of any civilization: water. And nowhere is this mastery more elegantly and impressively displayed than at the archaeological site of Tipón, located southeast of Cusco. Tipón is often referred to as an Inca water garden or an agricultural laboratory, and for good reason. It is a breathtaking example of sophisticated hydraulic engineering, a place where water still flows through ancient channels, as if the Inca engineers had just stepped away. What makes Tipón so remarkable is not just that it's a system for channeling water, but the precision and understanding of fluid dynamics it demonstrates. The site features a complex network of surface and subterranean canals, aqueducts, and stunning water drops or waterfalls that are not merely decorative but serve functional purposes. The water originates from a natural spring high above the site and is meticulously guided through these stone-lined channels to irrigate an extensive system of agricultural terraces. Consider the challenges: maintaining consistent flow, managing water pressure, preventing erosion, and distributing water equitably across a large area. The Inca engineers at Tipón addressed all of these. They constructed channels with carefully calculated gradients to control the speed of the water. In some sections you can see features that likely acted as energy dissipators or flow regulators, ensuring that the water didn't become too turbulent or overflow its channels, especially during periods of heavy rainfall or spring melt. Machu Picchu isn't just a wonder for its beauty, it's an engineering puzzle. Built atop two fault lines, the city rests on an intricate drainage system that prevents landslides even in torrential rain. Machu Picchu. The name alone conjures images of mystical beauty, a lost city nestled high in the Andes, shrouded in clouds and mystery. It is, without a doubt, one of the most iconic archaeological sites on the planet. But beyond its breathtaking aesthetics and enigmatic purpose, Machu Picchu is a triumph of civil engineering, particularly when you consider its precarious location and the environmental challenges it faced. This was not a city built on easy ground. One of the most astonishing facts about Machu Picchu is its geological setting. The citadel is built directly on top of not one but two active fault lines. In a region prone to earthquakes, this would seem like an incredibly risky, almost foolhardy place to construct a major settlement. Yet, Machu Picchu has endured for centuries. This resilience is not accidental. It is the result of deliberate and sophisticated engineering choices, many of which are hidden from casual view. The primary challenge in such a location, especially given the steep slopes and heavy seasonal rainfall, the region can receive over 70 inches of rain annually, is managing water and preventing landslides. Without the wheel, without writing, without modern metal tools, how did the Incas accomplish so much? This is the question that echoes through every site we've explored, every colossal stone we've marveled at, every intricate channel that still carries water. How did they do it? How did a civilization which by many conventional historical yardsticks lacked key technologies achieve such monumental and sophisticated engineering feats? The Inca did not have the wheel for pottery or transport. Though small wheeled toys have been found in other Mesoamerican cultures, they weren't applied to labor. They did not possess a system of alphabetic or syllabic writing like those in Eurasia. And their metallurgy, while advanced in gold, silver, and copper alloys like bronze, did not include the widespread use of iron or steel for tools. So let's consider the implications of these absences. Without the wheel for transport, moving multi-ton stones over miles of rugged terrain becomes an almost unimaginable challenge, relying solely on human power, ropes, ramps, and perhaps rollers. Without a written language to record complex calculations, architectural plans, or engineering principles, how was this knowledge developed, refined, and transmitted across generations and vast distances? How were massive, coordinated labor projects planned and executed with such precision? The tools available to Inca stonemasons were primarily harder stones used for pounding and grinding, supplemented by bronze chisels. While bronze is harder than copper, it's still relatively soft compared to the andesite and granite they were shaping. The process would have been incredibly slow and laborious, requiring immense patience and skill. Imagine chipping away at a 50-ton granite block with tools that constantly need resharpening or replacing. The sheer investment in time and human effort is difficult for us to fully grasp in our age of power tools and rapid construction. Want to see these marvels for yourself? So, after journeying through these incredible feats of engineering, perhaps you're feeling that pull, that desire to witness these ancient wonders with your own eyes. And I can tell you, there's nothing quite like standing in the presence of these stone giants, feeling the Andean wind on your face, and pondering the immense human effort and ingenuity that brought them into being. Visiting the Inca sites of Peru is more than just a tourist trip. It's an immersive dive into a world that continues to inspire awe and provoke deep questions. When you visit Sacsayhuamán just outside Cusco, prepare to feel dwarfed by the scale of its walls. Run your hands, gently of course, over the massive, perfectly fitted stones. Try to imagine the scene centuries ago, the sounds of stone being worked, the chants of laborers, the vision of the architects. Look for the different styles of masonry and consider how each stone was individually shaped and placed. It's a place that truly makes you appreciate the ambition and skill of its creators. Trekking a portion of the Capacnan, the Great Inca Road, offers a different perspective. Whether it's the classic Inca Trail to Machu Picchu or other less-traveled sections, walking these ancient paths connects you directly to the empire's logistical genius. Notice the paving, the drainage channels, the staircases carved into the mountainside. Imagine the runners speeding along these routes carrying messages that held an empire together. It's a physical connection to the arteries of Inca power. At Ollantaytambo, gaze up at the Temple of the Sun and contemplate the journey of those colossal granite monoliths. The Inca Empire may be gone, but its legacy is still literally set in stone. Which engineering feat amazed you most? Comment below, and don't forget to subscribe for more ancient mysteries uncovered. And so, our journey through the engineering marvels of the Inca Empire comes to a close, but the questions and the sense of wonder, I trust, will linger. What we've seen is more than just ancient architecture. It's a profound statement about human potential, about the ability to achieve the seemingly impossible through ingenuity, organization, and an intimate understanding of the natural world. From the colossal, perfectly joined stones of Sacsayhuamán, to the life-giving waters of Tipón, and the resilient citadel of Machu Picchu defying earthquakes and time, the Inca have left us an indelible legacy. These achievements, accomplished without many of the tools we deem essential, force us to reevaluate our definitions of technology and advancement. They remind us that there are many paths to innovation, many forms of knowledge. The Inca may not have left us written treatises on engineering, but their works speak for themselves, challenging us across the centuries. Their silent stones are eloquent teachers, inviting us to look closer, think deeper, and appreciate the enduring power of human creativity. Thank you for joining me, Ahmed Gaber, on this exploration. The story of the Inca is a testament to what a civilization can accomplish when it aligns its efforts with vision and a deep respect.